Thank you. Thank you. I'm super happy to be here. Bern's a beautiful city. So let's get started with a question. How powerful are the devices running your web apps? So when you write a web application, are you targeting desktops, if people still use those, laptops, mobile devices? They might be half the speed, an eighth the speed, depending on the device, right? What happens when you work at a place like Netflix and you have to target SmartTVs? SmartTVs are 465 times slower than your laptop. So what if you had to write apps that were targeted against that? Are you sure that you're only executing the code that's necessary? Are you 100% positive that all of the async code that's executing in your app is only firing when you want it to? Are you using promises? Who here uses promises? How many people? A lot of people. So what if I told you that by using promises, you might be triggering code that you don't want executed from time to time, wasting valuable resources? So when you move to mobile or these underpowered devices, you're running code on these tiny little CPUs that you don't want to. So I'm going to tell you about RxJS 5 and Observables. I think, can you guys still hear me? Okay, good. The RxJS 5 and Observables can help prevent this waste. My name is Ben Lesh. I'm a senior UI engineer at Netflix in the Edge Developer Experience team. I'm also the project lead on RxJS 5. You can find me on Twitter here. If you think of a question later, like after Jazoon or whatever, I try to answer all questions that I get on Twitter or that come through GitHub issues on RxJS. So I've said RxJS a whole lot and Observables, but what is it? What is RxJS? One way to look at it is Lodash for events. So how many people here have heard of or used Lodash? Good, good. Lodash, as you know, or most of you know, is mostly it's a library that allows you to do operations over sets of things, synchronous sets of things like arrays or iterables. Another way to look at it is Lodash for async. Asynchronous things in JavaScript are event-driven, so you can kind of swap those terms in and out, but mostly I'll be talking about async and asynchronicity in our web apps. So what are the types of asynchrony in web apps? These are the 5 most common that you're going to run into. The top one is Ajax. Then you've got user events. These are also extremely common, so you've got like your clicks and your mouse moves and key ups and that sort of thing. You've also got animations. Those are actually asynchronous. So you trigger an animation, you want to know when it ends, or perhaps you want to know when it reaches certain states, and you're going to fire events for those. Sockets, like WebSockets or maybe server-sent events, pump events at you, pump values at you over time. And of course, workers, which are sending events to you from a parallel process like another thread. So the way that you manage this classically in JavaScript before promises was callbacks. Since the dawn of async in JavaScript, you use callbacks for this. And how that works is you have a function that you give to a function. So you have a function that's going to start some async process, and you give it a function for it to call back to when it's done, a function that it's going to execute when it's complete. The problem here is that you run into what's classically referred to as callback hell. I like to call it the flying V, because a nice V-shaped thing. I don't know if you guys have seen the Mighty Ducks, but flying V. So to get rid of the flying V, a lot of us have recently, in the last few years, moved to promises. Promises are great. They solve this problem. They allow you to kind of chain these then calls that give you a handler that allow you to chain the async events one after the other and kind of flatten out that flying V. Makes it a lot better. It's a better functional paradigm as well. So let's talk about promises. Promises, these are the great features of promises. Sometimes people think I don't like promises because I work on RxJS. I talk about observables a lot, but these are the best features. They're a guaranteed future. It's in the name, right? It's called a promise. I promise to you I'm going to resolve or reject in some way. They're immutable. Once you have a promise, you can't change it. It's going to get a value eventually. They're a single value, making it good for Ajax. and they cache the value. So if it's resolved already and you keep it around and you come back and you call then on it again, you're going to get that same result out. So these are all great features of promises. However, in modern web applications, these two features will bite you from time to time. These two features make it not great for modern web applications. And let's talk about this. So guaranteed future. Why is that not great? It's because promises can't be canceled. There's some cancellation work being done. I'm not a huge fan of that, but promises are really, really great when you want that guaranteed future, and that there are times in coding that you do want that, but they can't be canceled, so that means you're probably executing code you don't want to, like I was talking about before. How is this? So here's my clip art chef lady. Clip art chef lady wants to use Netflix. So she's going to go in and she's going to look for a cooking show. And she's going to say, OK, let's watch Cupcake Wars. And I make this promise-based AJAX request to get some metadata about Cupcake Wars. And the spinner comes up, and she's waiting for it because her telecom service is really slow or whatever. And then she's like, nah, I don't want to watch Cupcake Wars. I want to watch Cutthroat Kitchen. So she goes and she selects that instead. Now we've got a problem. We've got two promise-wrapped AJAX calls in flight. And the server is definitely going to respond with both of them. And the Cupcake Wars one is probably going to come back first. But you don't care about the results anymore. And what's going to happen here is it's going to process that JSON request. It's probably going to parse it, whatever library that you have that's wrapping this in a promise is probably going to parse that JSON, or at the very least, the browser is going to handle the request and do some things in your XHR. And it's going to execute some code, and then you probably have some little mutable bit in here like, no, I don't care about this one anymore. I care about the next one, so just drop it. But you've executed code now, effectively, that in your app that you didn't care about at all. There was no reason to execute it. So a better scenario would be if she was like, OK, let's watch Cupcake Wars. And then she says, well, no, I don't want that. Let's watch Cutthroat Kitchen. And then we cancel the first one. So your XML HTTP request has a method on it called abort. And if you call abort, then that response when it comes back is going to just be dropped. You won't end up executing any code. Because make no mistake, the server is not going to stop processing your request because you told the browser to abort. The server is going to do its job. It's stateless. It doesn't know about these two requests or your browser's state. And it's going to process it and send it back, but now you're going to drop it. So that's the ideal. Ideally, we are able to abort our XHR when we don't care about it. And this is just one example. So this is, in modern web apps, this isn't great because, as Gerard was showing you in the last talk with Angular, and as you're going to see in Ember apps later, you have this stateful app, and you're going between views and routes. You're not dropping the page and reloading it every time anymore. That means anything that you executed async on that last route, if you are unable to cancel it, it will execute, and you'll end up executing code that you don't want to. So we want to type with cancellation. We know that much. For modern web async, we want some cancellation in our type. So the next problem we had was that promises are a single value. This is pretty easy to reason about when we think about our 5 common types of asynchrony here. There's only one of these that's really a single value, and that's AJAX. That's it. So promises aren't going to really work well for other things like user events. Maybe if you only cared about when your animation ended, you could use a promise for that, and it would be OK. But yeah, it only really works for AJAX. So we want a type that can handle more than one value. Well, JavaScript has a type for more than one value, and it's called the iterable. Now, an iterable basically is shaped like this. An iterable has an iterator method. Now, I want to clarify that the iterator method is actually the symbol.iterator method. But for clarity in my talk, I'm just going to call it the iterator method. And what happens is you call the iterator method on your iterable, and it gives you back an iterator. And then your iterator is actually more what does the work here. You call next on your iterator, and it'll give you a result. And that result will tell you whether or not the iterator is done. It'll tell you the next value from your iterator. And the other thing that it'll do is when you call it, it'll synchronously throw if there's a problem inside of your iterator. So you've got completion, you've got a value, and you've got error handling built into your iterable. So this is kind of how you consume it. The best way to consume it would be with a for of loop, but the for of loop internally is doing something like this, where you get your iterator from your iterable, and then you start looping over it, and you try to get the next result. If it errors, you handle the error. There's actually a bug in here. There's supposed to be a break underneath that handle error. And then the next thing you're going to do is to see if it's done and break if it's done. Otherwise, you're actually going to do something with the value. That's basically how it's consumed. But iterables alone aren't very good for async, because how would you use it to get something asynchronous? It's something that's going to happen at some later point, right? So you're going to poll it, put a setup and interval, then you're executing the code that you don't want to, right? Not to mention, it could come back and it could actually want to tell you that it's giving you an undefined value, and then how would you differentiate? So now you've got to create an object. It's a mess. You don't want to poll it. That's a bad idea. This is a better way. Iterator of promise. This is actually a very cool type. It's really good for back pressure. So iterator of promise, you'd say, give me the next one. It gives you a promise that's going to have your iterator result in it. And you're going to be able to handle that promise and use it however, for however long you need to use it, and then say, all right, give me the next one. So that's back pressure. You're making sure that you only get the results that you can actually handle. It has that promise, lack of cancellation thing in it again. And the other problem it has is it allocates a promise for each value. So you could imagine that's not going to be great on memory for things like mouse movements or WebSockets or something pushing at you. And the other problem with it is, since this is a pull-based async type, it's not really great for events that are being pushed at you. Again, mouse movements or WebSockets. So we need a different type. We need observable. And observable is really just an iterable turned inside out. That's why I went over iterable, actually. So how do you turn an iterable inside out? I'm going to start with the iterator, because the iterator, as I stated, is what really does the work for the iterable. And I'm going to turn it into observer, which is actually what does most of the work for observable. So the first thing that we do to turn it inside out is, instead of having a method to get a value, we're going to have a method that accepts a value on our observer. The next thing is, instead of synchronously throwing errors, we don't have to do that anymore because this is async. We can just have a method on our observer that you push errors into, so we can have errors pushed at us. And finally, again, we don't need to check result.done anymore to know if this is complete. We can just have completions pushed at us. So the observable can just tell you when it's done. You don't have to say, next, are you done? So this is the basic shape of an observer. There's a next handler, an error handler, and a complete handler built onto your observer. So the next thing we need to do is we need to actually finish pulling our iterable inside out. So we have our observer now. So how do we make iterable into observable? Instead of a method called iterator, or again, symbol iterator, to get an iterator, what we're going to do is have a method, we'll call it observer, to pass an observer to. But observer is a horrible name for a method, so we'll call it subscribe. And this, if anyone here has used Rx before, should look very familiar. Or if anyone saw, all of you saw Gerard's talk, you saw subscribe on an observable. So observable is the dual of iterable. And that's just a fancy way to say that you've taken methods that gave you values, and now you have methods that you're putting values into, just turning it inside out. But I haven't said anything about cancellation yet, and that was a big thing. We want cancellation. Well, we're in luck. Subscribe, we didn't have it returning anything yet. So we can have subscribe return a subscription that at any point later on, we can call unsubscribe on our subscription, and it's going to tear down our observable. So let's talk about tear down. So how do we define, what do I mean when I say tear down? Well, when you define an observable, it looks like this. So you've got this observable constructor, and you pass a function to it. Now, this function accepts an observer. The function inside is really, this is the observable. When you think of your observable, when you think of what happens when I call subscribe in my observable, it calls this. There's no real magic mystery to what's happening inside of the observable type. You can think of it as a function, and functions are lazy, so they don't do anything until you call them, right? The same thing with observables. They don't do anything until you subscribe to them. So when you subscribe, it calls this function. That gives you an observer, and we can push values out to it by just simply calling next on our observer. So in here, I'm incrementing a value, and I'm pushing it out of my observer. Now, the cancellation part is really, we've got this set interval, and I'm setting up an interval in here, and what I can do from that function I'm passing to my observable constructor is I can return a function that's called when you unsubscribe, or when it completes, or when it errors. And this will tear down my interval. So that this is the observable then, when you subscribe to it, it's going to set up, it's going to set itself up, it's going to set up its underlying resources, it's also going to set up the teardown logic for you, and that's going to go into your subscription. So that's it in a nutshell. This is a very basic observable and how all observables are created, even inside of operators in RxJS. So observable, just to refresh, is any number of values over any amount of time. They're lazy, so they set up observation and resources when you subscribe to them, just like a function. Until you subscribe, it's just like calling a function. They're cancelable, so you can tear down your observation and your resources at any point just by calling unsubscribe. Laziness bonus, I do love that phrase, laziness bonus. They can be retried or replayed simply by calling them again. Again, you saw that retry when operator in Gerard's talk. There's retry, there's replay, which just says, hey, if this is successful, run it again. But yeah, that's an awesome feature of this. And they can be thought of as functions. So observables give us sets of events. We have sets of events now, and why is that cool? Sets are cool because sets have operators. They have operations that you can use on them. So here I've got some iterable. This could be an array, for example. And I'm calling filter, map, and then for each. So filter is going to narrow it down to a smaller iterable. Map is going to map it into an iterable with different values. And then for each, I'm going to create some side effect. In this case, I'm calling some print function with the values that I'm getting out of my iterable. If I'm going to have operators in observables via Rx, it'll look exactly the same. For each is just actually, it's another way to subscribe to observables. So RxJS has operators. We have filter, map, and reduce, which you might have already been familiar with from arrays in JavaScript. There's another one called scan, which is similar to reduce, only every time it reduces the value, it emits that value that it's reduced to. There are other ones, skip, take first and last. Anyone who's used Lodash or .NET IEnumerable is going to be familiar with these. Skip so many, take so many, give me the first one that matches this, and so on. These are great. These are merge strategy operators. I'm going to talk about these in just a minute. Merge, concat, and switch. They're very important. These are the key to not wasting your resources and kind of building things into a nice functional flow. Zip, combine latest with latest from. These are operators used to combine two different observable streams. And then finally, repeat and retry, which I've already discussed a little bit, which are just for, oh, something's gone wrong in my observable, let's retry it, or my observable is complete, let's do it again. So let's talk about an operator, the simplest operator in the world, map. And one of the reasons I want to talk about this is partially to introduce these dashed lines at the bottom. These are called marble diagrams. It's a bit of ASCII art, and it's always put together with a fixed width font so you can kind of line things up. And what I've got here is I've got a source observable that I'm calling map on, and that's going to return to me a mapped observable. And what will happen is I can subscribe to my mapped observable, and it will subscribe to the source. And each one of these dashes represents the passage of time. And then when I get a value from my source, it's going to emit the mapped value, that projected value, in my mapped observable. And so on. It's going to keep doing that for every value that comes in on my source. And the pipe at the end signals that my source is completed, and that will complete my mapped observable. So this is a very, very basic way to think about or represent how things can happen over time with an observable. But right there, I just dealt with something that was totally synchronous, just adding numbers together and emitting them. But what happens when you want to map into something asynchronous? So a scenario might come up where my source here is mouse clicks on a button. And every time I mouse click on a button, I want to do some AJAX call. Right? And my AJAX is going to be wrapped in my favorite type with cancellation, which is an observable. What do I get there when it comes out mapped? Where those question marks are, I've got an observable of HTTP response, right? So if I subscribe to that and I was just to log it out, I would, as soon as I clicked, I would synchronously get object in my console, right? It wouldn't be very helpful for me. So what do? We need these merge strategy operators. Basic merging strategies, which are called merge, concat, and switch. And there are variants of these built into RxJS. So the first one I like to talk about is merge all, and I like to talk about this one first because it's the simplest of the merge operators. And what this is I've got this observable up here. It's a higher order observable. It's an observable of observables, just like the example I showed before. And I'm calling merge all on it. And the result of that is an observable of values that have been flattened. So to go over this, when I subscribe to my result, it's going to subscribe to the source. When I get the first observable from my source, because remember it's an observable of observables, that capital A, I'm going to subscribe to observable A. And as soon as it gives me a value, I'm going to send it out to the result. Then when I get another observable from my source, I'm going to subscribe to it immediately. And now I've got two inner observables there in flight. I get a value from A, I push it out. I get a value from B, I push it out. I get a third observable, I subscribe to it, get a value from A, get a value from B. Now, the first one's completed, but I've got two more in flight and my source is still active. It's not completed yet, so my result doesn't complete. I get another value from C, I get observable D, I subscribe to it, and then I pump the values out. B is complete. My result is still not complete because I still have more observables in flight. C gives us a value. D completes. We're still not done because the source isn't done. The source completes, but we're still not done because C is still active. And when C completes, we're done because the source is done. I can't get any more observables from it. So essentially what merge all does is it takes all the observables it gets, subscribes to them immediately, and then pushes all their values out to the result. So it's a way of just merging all of the values from a set of observables that comes to you over time together. The next one I want to talk about is concat all. This is very similar to merge with it only does one concurrently. So what's going to happen with this is when I subscribe to my result, it subscribes to the source. When it gives me the first observable, I subscribe to it immediately because I'm not already looking at an observable. And I pump the value to the result. When I get the second one, I'm not going to subscribe to it. I'm going to buffer it. So that's something to be aware of with a concat operator. It's got an internal unbounded buffer. I'm going to buffer it, and I'm going to finish the first observable I got. I don't care if my source completes, because what's important here is concatenating all of these observables I've gotten so far together. When the first one finishes, then I can subscribe to the second one I've got. I pull it out of the bottom of the buffer, and when it completes, I'm done because my source is already complete. So you can think of concat all as taking a series of observables over time and then playing them back to back with each other. If there's a gap between one observable finishing and the next, it'll just subscribe to that one immediately. But if you have one in flight, it's going to wait until it's done. Finally, switch. And this is the most important of these merge strategies, I think. This is the one that you use to solve our problem with our two HTTP flights, like two HTTP requests in flight. What this is going to do is I subscribe to the result, and it subscribes to the source. The first one it gives to me, since I don't have an observable I'm already subscribed to, I go ahead and subscribe to it immediately. And I take some values from it. But when it gives me a second one, this is where it gets interesting. What I do is I say, oh, I want to switch to this new one. So I unsubscribe from the first one that I got, the one that I already have, and I don't care about the results anymore. And then I subscribe to the new one, and I take values from it. When I get another observable from my source, I'm going to switch to that one and play the rest of it. And if the source completes before my inner observable completes, we're not done. We wait for the inner observable to complete, and then we're done. So switch, it's called switch because it switches between the observable it already has and the one you give it now. So there's different variants of these things. I'm going to blow through this very quickly, but there's a static merge where you can give it a static set of observables you want to merge together. There's a member version of merge, which is the same as static. It's similar to like array concat sort of idea. Then there's merge all, which I just went over. Then there's this one called merge map. This is also known as flat map, and it's aliased in RxJS 5. But we call it merge map now because it makes it easier to explain, because what it is it's the exact same thing as this, mapping to an observable and then calling merge all. So merge map is map to an observable, then merge. We could have called it map merge, but I like merge map better, I guess. Concat variants are very much the same. Not really that different from the merge variants. The same with concat map is map to an observable and then concat all. And then switch variants are a little different. There's no static version of switch because that wouldn't make sense. That's just like, hey, subscribe to the last one I gave you in the static set. Switch we already talked about. And then switch map, which, as you might guess, is the same as mapping to an observable and then calling switch. So switch map is also the same as in older versions it was called flat map latest. And that it was hard to explain to people why it was called that. So switch map is a little easier because it's more formulaic. So examples. If anyone here has a flask of something, get ready. The drinking game is that when you're listening to an RxJS talk and someone mentions stock ticker autocomplete, take a drink. I kind of like that idea. So drink up, here we go. It's a super lame autocomplete example. What I want to show you here, though, is this is the network panel on the right-hand side from Chrome. And you can see our autocomplete call getting canceled there, the second one, just because the timing happened to be right on my throttled key presses where it said, oh, the server hasn't responded yet, but I want to send a new request, so let's cancel it. Let's abort that XHR. We don't want to execute that extra code. So this is solving my clip art lady's problem right here. This is what the code would look like if you wrote it in plain JavaScript. You don't need to like grok that if you don't want. Basically, there's some bits of mutable state in there. It's kind of gross, but this does exactly the same thing as what you would see in RxJS. But this is the code in RxJS. I'm going to walk through this in just a second. But you can see it's practically a one-liner if your linting rules let you write it all in one line. Or if your team let you do that, don't do that. But it's pretty short. So let's talk about what that code was doing. So first I have an observable of key up events. And what I'm going to do is I'm going to call debounce time on them. And what this says is, oh, for every event I get, wait 500 milliseconds. And then if I haven't gotten another event, go ahead and send that one along. So anything that gets past this point in my observable chain is something that we want to send as an AJAX request because we're debouncing it. And I'm going to use switch map here, which is, again, it's going to map to that AJAX get call inside of there. And that AJAX get call is going to return some observable of my AJAX request. And then it's going to switch to it. So in the case where my server takes longer than 500 milliseconds and I pressed another key, it's going to get in here and be like, oh, well, I need to cancel my other AJAX request, and then I'll just use this one. And that's really it. After that, we can go ahead and subscribe. And we can use the values that we get back from our AJAX request we can render it. So this is a simplified walkthrough, but this is basically what's happening in there. So this is another example. This isn't a stock ticker, I'm sorry to say, so put your glasses down if you did bring something. I think all we have is orange juice anyway, so it's fine. So what this is, I call this the meetup-atron. I made this for a meetup about a year ago in RX4, and I've ported it to RxJS 5. All of this code's online. I'll link that on Twitter later. But what this is doing is this is demonstrating a multiplex WebSocket. Now, multiplex WebSockets are a difficult problem to solve. What a multiplex WebSocket is you're saying, I want to use one WebSocket to transfer many streams of data. And this is a problem that I solve at Netflix frequently, actually, on our apps. And the challenges here are this. What you want to do is you say, OK, I don't want the WebSocket to be open unless I have a data stream. So don't open the WebSocket until I'm actually subscribed to something. And when you're clicking each one of these checkboxes, it's saying, OK, give me the data stream for people thinking about the talk or checking their phone or the people that really have to go to the bathroom. When you check one, it's saying, OK, well, if my WebSocket's not open, I need to open it. And then I need to send a subscription message to the server. And then I need to get the results from the server, I need to filter out the ones that I care about for this particular data stream. Now, this gets really, really gross when you start to consider, oh, I've got a WebSocket, and I work at Netflix, and people walk out of the building and go to another building, and they lose Wi-Fi connection. Guess what? Your WebSocket's dead. It's not going to reconnect itself. You've got to do that with your code. So how do you do that in imperative code? It's hard. You've got to track your subscriptions and then reconnect your WebSocket, replay all your subscriptions. Or in RxJS, you can just call retry. But here is a multiplex socket in plain JavaScript. Very small because I had to take 2 screenshots to fit it all in. This has retry logic built in, lots of really nasty mutable state. It would be very hard to test. This is a multiplexed WebSocket in RxJS. I'd love it if we had time to walk through this. Maybe we can talk about that after in the backstage. But really, the top 5 lines of this is mostly boilerplate, to create the WebSocket subject, and all of the logic is the bottom, maybe 2/3 of it. That's doing all the logic for my my multiplexing and my retrying when it goes south on me. So Netflix clearly likes RxJS. We love RxJS a lot. We loved it enough to pay me to work on it, clearly. So why would we rewrite it? RxJS was great, when I started at Netflix, and RxJS 4 is still great. Why would we create a 5th version? And these are the reasons. Top reason was performance. We have, as I stated, these devices that are 465 times slower than your laptop. Really, really tiny little things that we have to run stuff on. And we also needed better debugging. Debugging in RxJS 4 is difficult. I don't know how many people here have tried it, but it's difficult, and I'll get to why in a little bit. And then we also wanted an observable type that matched the ES observable spec. There's a gentleman that works at Netflix who's on the TC39 named Jafar Hussain, good friend of mine, that is working with Kevin Smith on this spec. And what the spec is it's a proposal for adding an observable type directly to JavaScript. So ideally, at some point, RxJS would just be able to use that observable type, and it would be a set of operators on top of that. And the only way to get there is to build RxJS to mirror that observable type. And the other thing we wanted was increased modularity. If you're deploying on very, very inefficient or weak devices, it's good to keep your bundle size down. And I'll talk about that in a little bit, too. So old RxJS performance was pretty good. Unless you're running on weak hardware or Node at Netflix scale, then every operation counts. You want it to be very, very fast. So in order to accomplish making RxJS faster, we started with a performance-first way of development. So this basically meant that we developed a set of performance tests before we even wrote code against this. We had micro-performance tests. What that does is usually just gets timing against a bunch of iterations of executing some code over and over again. And then we had macro performance tests, and this a big thank you to Google's Angular team who worked with me on this to add bench press. We had a preview of bench press to do this. And what a macro performance test is this. It actually runs it in the browser, and it will give you information about memory usage, obviously timing. It'll give you information about garbage collection, and these are all things. Garbage collection blocks threads in your browser, so it's important to be able to manage these things. And what we did is we got common scenarios inside that you have when you're using Rx, and we ran those. And these common scenarios we were looking for are common scenarios where we might be creating a lot of object instances or instantiating a lot of arrays or things that might cause a lot of garbage collection or memory usage. Then we tried about 4 or 5 different architectures. The one we landed on is something called a lift architecture. That is an entire talk in itself, but what I can tell you is if you're really deeply interested in Rx, go to GitHub. I would recommend doing this with your favorite projects anyways. Go to GitHub, look through the source code, find the lift operator on Observable, and kind of trace where it's used, see how it works. Basically, it's involved in every operator call in RxJS, almost everyone. So, and then new additions or changes to the library or even bug fixes were run against performance tests. So if you fixed a bug but you halved performance, then we really needed to debate whether or not we fixed it the right way or if we needed to fix it in a different way. or maybe that's it and we're stuck with half the performance. We didn't run into having performance, but there was some times where there was like a 10% cut in performance to fix some bug or something. So new additions, yeah, new additions, the same thing. Someone says, hey, I want to add a new operator. Well, you better write performance tests against it because we want to make sure that it's up to snuff. So what we found when we were developing this stuff is we wanted to fast track scheduling, and we want to reduce closures. So what is scheduling? Scheduling is a thing where you're saying, I want to schedule this little bit of code to act at some later time. The thing with scheduling, the reason it's slower is it creates some overhead in terms of function calls or object allocations. You're sticking things in arrays or what have you. Scheduling hurts debugging because it knocks over the call stack. I've got a visualization to show this here. And then older versions of RxJS default to what's called trampoline scheduling. So real quick, why would you schedule? The reason you schedule is, well, I'll show you right here. We've got recursive scheduling. So what recursive scheduling is when you call a function within a function. So if you develop in JavaScript, which I'm assuming everyone in this room does, congratulations, you are recursively scheduling your code. It sounds way cooler when you say, I'm recursively scheduling. I'm not just calling functions. So if we have function main and it calls function 1 calls function 2, and function 2 calls function 3, and so on, we end up building this stack of function calls. If I have an error at function number 9, my call stack is going to show function 8, function 7, function 6, and so on, all the way down to function main. So when you look at the call stack when you're debugging, that's what you see. The problem with this is that if you get your call stack up to 256 calls, Stack Overflow. Sorry. So when you write, if you want to traverse a tree in JavaScript and you're saying, OK, I'm going to traverse this tree, I've wrote my recursive code, it's like, OK, look at this node, and then if it's got children, then call myself again, and so on. Thank God that you haven't worked on a tree yet that has more than 256 layers of nodes. Because if you did, you'd get a Stack Overflow, and you might be scratching your head. So to solve that problem, people use a trampoline scheduler. And this is how it works. So we might have a function main, and then we have main calls function 1, but function 1 is going to schedule function 2. Function 2 calls function 3, but function 3 is going to schedule function 4. And since it's in a stack that was scheduled in function 1, that means function 4 gets dumped over, knocked over onto function 1. Then it calls function 5 schedules function 6, and so on. So if I have an error on function 5, top middle there, and I look at the call stack, it's going to show me function 5, function 4, probably some scheduling gobbledygook, and then function 1 main, right? I have no context. I don't know that function 3 is what called function 4. So that's why debugging is hard with this type of scheduling. So we worked that out by basically what we do now in RxJS 5 is we default to recursive scheduling because it's actually a rarity that you're going to hit the need for trampoline scheduling. You can force trampoline scheduling by providing a scheduler to your observable creation, or by using an observe on or a subscribe on. You can force the scheduling of your subscription or your observation, but for the most part, we just default to recursive, which is much, much faster and better debugging. The next thing we had to do to increase performance was reduce closure. Now, what closure is this. It's when you have a function that closes over some external variable. And what happens when this function closes over this external variable is it's going to allocate scope when you call it. Now, older JavaScript engines always would allocate scope, but modern JavaScript engines will optimize those allocations away if you're not closing over variables. So what allocating scope means is basically like it's allocating an object in memory that you didn't make to hold that variable so it can access it later when it's running the code. So I want to note before I get into how we eliminated closure, closure is generally a good thing. RxJS is a very, very hot code path. It's a low-level library. Do not go back to your workplace and start I'm eliminating closures. Ben Lesh said I should eliminate closures. That's a really bad idea. Closure is generally a very good feature, especially for functional programming. This is something we did to make RxJS 5 faster. So yeah, don't optimize that way in your apps. Unless you have to, but you probably don't. So eliminating closure method number 1. The first method is so we've got this closure, same thing. We're closing over foo with bar, our function bar. And so the idea here is you have some long-lived context, some object, usually a prototype on a class that's going to stick around for a long time, and you just put that foo variable on that object, and then you can access it with this inside of your bar method on that object. So that's one method. Now, if you were to allocate this object every time you called the function, then you're not buying yourself anything. So the long-lived part is important. The other method, and this one's pretty weird. I actually didn't think this worked when someone first told me this one, but you can check it, especially in Chrome. Is what you do is you have a named function you assign to a variable, and then that variable you can give it a property on the outside of the function. Here I'm saying bar.foo equals foo. And then inside the function, I can use the function name to pull that property out. And this does not create a closure. If you're skeptical in the audience, I was one of you once. I argued it tooth and nail. There's no way. But this actually does work at optimizing that function, and it does make it a little faster. The other method's a little better, though. So performance improvements. Overall, RxJS 5 is 5 times faster on average, operator to operator, than RxJS 4 was in V8. On our resource-constrained devices, so these are the devices that are 465 times slower than your laptop running Chrome or Node, 600 megahertz ARM processor, single core, with a 16K L1 cache. It's tiny. It's tiny. I was a very young man when I last developed against something like that. Yeah, it's about 3 times faster in those devices, and those are also non-jitted runtimes and stuff too. So some of the optimizations we don't get. The highlights. So these are all hot code paths for Rx. So flat map, which is also known as merge map, is 10 times faster. Do, which is what you use to create a side effect in the middle of an observable stream, is 20 times faster. From and of are used to create observables, 10 and 17 times faster. And then switch map, which used to be flat map latest, is about 9 times faster. And these are all really important operators. So I'm super excited about the performance there. Another improvement we had is with modularity. Gerard touched on this in his talk a little bit, but the idea is you can import only the operators you want to use. So here, I'm importing a map operator, and I'm just calling it on Observable. So this isn't patching like Gerard was showing. This is me just importing it and using it. And if you're using Babel, you can use the ECMAScript function bind proposal in Babel with Babel function bind, and that gives you this little : : These two things are the same thing. It's just this enables me to write it in a prettier way. So I can treat map like it's directly on my result of. Here's the one that Gerard was showing. This is patch operator. So this is literally going to patch your prototype on Observable with that map operator the first time that you import. And you can do the same thing with CJS if you're using CJS. So literally the same thing. So the modularity win is that you only bundle the operators you need. So a lot of complaints about RxJS before where there's 100 operators, I'm only using 7 of them. I don't need all this code being downloaded with my app. Now if you're using a bundler, which hopefully you are, be it Webpack or Browserify, TypeScript or something, it's only going to bundle in the operators you're actually using. An additional win, this is an idea that came from Andre Staltz, and I got to implement it, which is really fun. I'm pleased about. This is the same marble diagrams I was showing you, but we're able to use them to write integration tests. So this is an integration test on merge map, where we're testing merging about 7 or 8 operators, 7 or 8 cold observables coming through in a hot observable. This is just one of about 2,200 tests we run in under 2 seconds with this. And this is all the code you have to write to test this scenario. It's obviously pretty advanced. This is the code you would have had to write in RxJS 4 to test merging 3 observables. So if you can just imagine the scale of it if you tried to have a test like what I was showing here. So it's a big win, and I think it's much more readable and approachable for people that are new to it because it gives you a visual representation of what's going on. So RxJS 5 makes Rx great again. That's my Trump reference for now. I'm not a Trump fan. I'd like to make fun of him more than anything. I hope he watches this talk and hears that. I'm sure he's really into JavaScript. So better performance, improved modularity, cleaner call stacks by default because we're scheduling recursively, and an improved integration test story, which you just saw. So what's left for release? Right now, RxJS 5 is in beta, and in the next few weeks, I want to do a production release of it. The API is very stable. There's some cleanup we want to do, and we really want to shore up documentation. Andre Stals has been working very hard on the documentation for us, and it's starting to look very good. And there's some minor reorganization. Like we've got WebSockets and AJAX stuff built into the core right now, and we want to move those out to their own package. So that's it. Questions, comments? It's a lot of information. Yeah, go ahead.
Let's wait so I can come with micro. It's working already? Yeah. I've been reading a lot about Redux, and my question is, how does it fit together? Are they do they fit together or not at all, or what's your?
Generally people tend to choose one or the other. So Redux, the pattern is usually you dispatch events up to some store, and then the store has these reducers in it that update the store, and then it distributes an event down and says, hey, my store's been updated. You can implement that in RxJS in a few lines of code, honestly, and some people will do that. It's really up to the individual. I know a lot of Redux is a very Facebook sanctioned technology. So some people, I think, feel more comfortable with that. And it does take some Rx know-how to implement it. But it's like a scan operator and some other things. So usually people choose one or the other. If you wanted to use them both together, I would say that you would end up having to have observables that then dispatched to the Redux store. And then you're back to the scenario where you're bringing everything up to the top and then sending out this object into props, and then trying to control your side effects with should component update or some sort of immutability, where that gets in some acrobatics. The reason that people like to use observables for the same thing in React is it makes it so you don't have to worry about as much about immutability or should component update in all of your components, because you can wire the observable up to the top and then wire an observable back down directly to a component and then subscribe to it in there, and then that only that component's updating. Where in other scenarios, managing updates, renders in React can be very hard. For example, you could have a render method that has a component in it that says onClick, and then you have an arrow function inside there. Now, every single time that render method comes through, it's going to give a different function reference to that onClick prop. And then when the internal logic of React says, hey, do I need to re-render this? Has anything changed? It'll do a reference comparison of those functions and be like, oh, I do. This function changed, even though it's exactly the same thing. So I tend to prefer using Rx to Redux, but I don't fault anyone for using Redux because it's more sanctioned, and there's a learning curve to Rx as well. So, good question.
Okay, thank you, Ben. There's a little present for you for giving the talk.
Fantastic.
And there's going to be a 10-minute break, only a short one, so please be back in 10 minutes for the next talk from Mike. Thank you.